Today we will be talking about angle relationships, how one angle might compare to others. So first we are going to talk about a couple terms. There's always going to be some new vocabulary. So the first thing we are going to talk about, we're going to look at this figure up here. We have two intersecting lines. They share a point. And some of the angles, we marked how much the angles are. So we have angle MRN is 160, angle NRQ is 20 degrees, angle QRP is 160, and angle PRM is 20. Okay, so we have two angles that are 20, two angles that are 160 degrees. Okay. So the first term, congruent angles. Congruent kind of means the same as equal, but in geometry you don't use the word equal as much, but we will later. Congruent means that the two measures are the same. So in this case, we see that we have two angles that are 20 degrees. So we could say that angle MRP and angle NRQ are congruent because their measures are equal. We can say their measures are equal, but the angles are congruent. That's a little bit complicated, and I will keep correcting everybody, to say that angles are congruent, but their measures are equal. Kind of weird. Just like there are two angles that are 160, so we could say that those two angles are congruent. The next one are vertical angles. Okay, we can see when we drew these two lines and they intersected at a point, the angles that are directly across from each other, those are called vertical angles. They share a common vertex, and they're right across. And vertical angles are always congruent. That means their measures are equal. So you can see that we have angle MRN and angle PRQ. They are vertical. They are across the vertex from each other. So their measures are equal. We can say that those two angles are equal. The same thing are true for these smaller angles. They are right across the vertex from each other. They are vertical angles, and therefore their measures are equal and they are congruent. Okay. Adjacent. Now, if I had another person standing right here next to me and say that we are shoulder to shoulder, we are adjacent. We are next to each other. In geometry, we have a term called adjacent angles. Those are two angles that are next to each other and they share a common vertex and ray. So let me show you an example of that. I'm going to draw this angle and I have my vertex. And now I'm going to draw another angle right here. So I have this angle and this angle. They are adjacent because they are right next to each other. They share a vertex and they share this common ray. They are adjacent. They are right next to each other. Let me draw one that looks kind of the same, but not really. I'm going to start with this ray right here, with this endpoint. Now, if I drew another point right here and drew this angle, they don't share a common vertex, nor do they share a common ray. Okay? It's not exactly the same. So these are not adjacent angles. Now we will look at two terms that many people get confused. Many people get confused, and we just have to commit these two to memory. Complementary angles is when two angles equal 90 degrees. So we can see here that we have angle PQR and angle RQT. And together they form a right angle. And a right angle is always 90 degrees. So we say they're complementary. Now, they don't always have to be adjacent. Can you see how these are adjacent? They share a common vertex and ray. We just had adjacent. They could be separated too. I could have had this angle And then I could have another angle down here. So I could say something to the effect like, if this one is 50 degrees and this one is 30 degrees, when I add, or I'm sorry, let's make it 40 degrees to make it actually work. 50 degrees and 40 degrees, when I add those together, they get 90 degrees. So therefore they are complementary. I could do the same thing here. If this is 50 degrees and this is 40 degrees, I can say that these two angles are complementary. Complementary. Okay? Then we have one that looks almost the same. Supplementary. And supplementary angles are when two angles or more, I should say two or more angles, when we add their measures together, we get 180 degrees. And we know that a straight angle, we learned that in our previous lesson, a straight angle is always 180 degrees. So when you see a figure that looks similar to this, where you have a line and you have another ray coming out of it, those form a pair of supplementary angles. But those two could be separated into two things. So whenever their measures add up to 180, they are called supplementary. A lot of terms, I understand that. So why do we need to know that? Well, guess what? We can start to do problems to find measures of missing angles. So if we look at our first example up here, we have a right angle. So this outside angle is a right angle. So therefore we know that this is 90 degrees. And then we have another ray coming out. We have a set of adjacent angles, and they are, since these together make 90 degrees, they are complementary. So I know one of them is 55 degrees, but I don't know what this one is. We labeled it A. Now notice that that is a lowercase a. In our previous lessons, we learned about naming points and naming lines and line segments and rays, and we were using capital letters. So here's where there's a difference between a capital letter and a lowercase letter. When we refer to a number, so a measure of an angle or a length of a segment, numbers, when we represent them with variables, are always lowercase. So we have this angle that we know, 55 degrees, plus one that we don't know, that's A. We know that together those equal 90 degrees. And now we have a one-step equation by adding. So we are going to subtract 55 degrees from both sides. This disappears. We're left with A equals 35 degrees. So we just found that missing angle of 35 degrees. Let's look at this one. We have a set of supplementary angles. Supplementary, remember when we have a line and a ray coming out of it, that forms a pair of supplementary angles. We know that together these two angles equal 180 degrees. So we have one that says 75, one we don't know. We labeled it B, lowercase b. So now we can say 75 degrees plus B equals 180 degrees. One-step equation, we're going to subtract 75 from both sides. That drops off. We're left with B equals 105 degrees. Okay. Here we have two intersecting lines. And when we have intersecting lines, it forms vertical angles. Okay. The vertical angles are the ones that are directly across the vertex from each other. And they are always congruent. Their measures are always the same. So if we know that one of these is 51 and we want to know what this one is, they're right across the vertex. So we know that this one is also 51 degrees. All right, let's look at this final one. We have a little bit more complicated diagram. We have a line here, line FH, okay? And then we have two rays that are coming out. So we know that since this is a line, this whole measure is 180 degrees. These are, all three of these angles are supplementary. Okay. I'm also telling you that angle JGF, so JGF, that's this one, and KGH are congruent. So I'm telling you that these two angles are the same. So let's do something. We have to figure out, we're trying to find out what they are. We know that they are the same. So let's give them a letter. Let's give them the letter M. Lowercase m. We know they're the same. Now we know that the sum of all of these angles equals 180. So we've got 136 plus m equals 180. So now what's m plus m? If I have one m and another m, I have 2m. So I'm just going to simplify that a little bit. So I have 136 plus 2m equals 180. I'm going to subtract 136 from both sides. Over here, I get 44 and 2m over here. And then finally, I'm going to divide both sides by 2. I'm just going to, I ran out of room here. M equals 44 divided by 2, and that is 22. So each of these is 22 degrees. And that is using angle relationships to solve